This is my video number 35, Intelligent Documents. I want to look at a new world of smart documents. Right now we have artificial intelligence that's supposed to generate knowledge and intelligence, but we have no place to put that. We need to look at, if we want progress, we need to be able for the creator of this knowledge to be able to actually represent that in digital form. Whatever it is, mathematics, dance, music, physics, chemistry, bricklaying, hair cutting, baseball, football. All of these, every technology uses the computer to represent their technology, and yet we have no way to put it in there. So we'll look at the history of documents, where I won't start with cuneiforms back in about 3,500 years ago, but I will start with movable type that created in China on porcelain to be able to reproduce paper documents, and that was in 1044. And then in 1455 we moved that and were able to produce the Gutenberg Bible with movable type, and I think those were either lead or wood. And then in 1725 we started using punch cards to represent knowledge, numbers mainly, programming, that kind of thing. And then in 1830 we created Morse code so we could transmit information, dashes and dots, but in actuality it was binary. And then we had the teleprinter in the 1830s that could print this out, so we were able to create documents of the information that the Morse code represented. And then in 1835 we finalized our alphabet that we use today, A through Z. Before that, it had been different characters. And our telegraph system, which was to send the information to another system, which was our internet back then, which was 1844. And then our typewriter was invented, so everybody could create documents. And then we had the start of our TV system, which was a cathode ray tube in 1897. And a random access memory for our first computers was in 1948, right after World War II. And color TV demo was in 1949. And then we had magnetic storage created for our computers in the 1960s, maybe some more before that, but around that time. Then we had our ASCII 7-bit code designed and formalized in about 1963. It's gone through a whole lot of changes over the years, but we still call it ASCII. And then we had our IBM PCs version 1, 5¼ inch floppies in 1982. Now our document editors, a little bit of history on that. We had our key punch in 1901 to do numbers, put that punch out. And then in the 1930s, we had the IBM key punch, which would allow us to program and build data records. And then we had the IBM code pages, which was the representation of all the different language character sets for all the different countries. And then we had our first line editors. We probably had a few more before this, which was in 1960. And that was a command line editing. Then we had WordPerfect, which was a popular line editor in the 1970s. And then in 1978, we came out with WYSIWYG, which is our editor of like Notepad, which is what you see is what you get. And Microsoft Word came out in 1983. And Venture Publishing, which was one of my favorites, which would publish a whole book with chapters and indexes and the whole thing, which was in 1986 from Xerox. Our current computer language documents are programming, the documents that we use to program with are created using a typewriter or a key punch. That's it. You look at your keyboard, realistically that's our typewriter. Same character set, very limited, and very difficult to program with because we don't have any characters for hardly any representation of any technology. It's black and white. We can't use color, we can't use underlining, or all these things that we really could use because it's not on our keyboard. We'd have to do special something. Yes, we could create separate applications to do that, but I'm trying to get away. I'm trying to create a technology here, not try to force what doesn't exist in our current technology. And then we have ASCII. We're still using 79 characters. Oh, you want to go to Unicode? Okay, well, that's a /U5917 or something. Nobody wants to program that way, even though we could in some applications. It's a nightmare. And so we don't go that way because it's far, far too impossible to represent characters once you get out of ASCII reliably. So our lines are one-dimensional. Our fonts, our characters are one-dimensional. Basically, it's along the x-axis, one line we type in, and then we move the paper down, and we back up the line again and type in a new line. This is our editing. This is our technology and we could do this on the typewriter or we could do this on the key punch. And so our applications, just the structure and organization of our application that we build, our computer languages, are segmented into folders by type. So in this folder we may put, and then in the folders we partitioned into files by type. And then source code is partitioned into functions. So we separate our logic into small enough parts for the human to comprehend. In producing an application, we are producing thousands of documents, of files and folders, and just to build one application. We may be using 3 different languages. We use JavaScript, and then we use PHP, and then we use Python to move. And then we have all the scripting language. Oh, these will compile it. This will load it. This script will load it into an executable, and these scripts will install it, and these scripts will transport it. So we have all these other scripting languages that are all manual operations. This is not one technology. This is not one document. These are thousands of documents, are impossible for the human to really manage. So we have no progress. So we cannot improve any technology without improving our documents. Supply no method to create the required documents to our editors. We can't create mathematics, not as we write on paper, or dance or music. Or our whole document technology has not improved. And it's hard for anyone to create a new editor because we have to go back. If I want to create me personally, I'm going to be creating an editor that can do all this, but what I need is 2-dimensional font. I need something that has enough information and is done accurately enough that we can do mathematics without doing special spacing based upon the one font that we can actually get to work, because they're all different sizes, and so it's almost impossible to build those technologies to be reliable. So if we can get better documents, intelligent documents, it's going to be means that we can get better technologies. So we can represent mathematics as we read it. And when our source code, we get where we could actually read our source code and we could understand it. Right now, the way we write software is we write the code and our only test is, does it run? That's our development technology. Okay, does it run? Yeah, I told it to print hello world. Ooh, I see it. Ooh, isn't that great? We're really moving along now, ain't we? We can't tell before we run it if it's actually going to work. We have to so we need better computer languages, that's for sure. I mean, we need one all-powerful that can do computer languages, put in maps, tables, and grids. I mean, information is part of our is part of our language. We need to be able to represent that in any form that we think. It could be a table or a grid, or it could be dance steps, it could be music notes. Who knows what technology somebody's going to come up with. So we need actionable, functional, shareable documents. And we need to go to a term-based technology, not character-based. So our whole technology right now is character-based. Oh, here's an A, here's a B, here's an X, here's a T. What does that spell? I don't know, but somebody typed it in. And so But what we need to do is we need to go where we looking at words, not character, and it has to do with parsing. What does this character mean? What does this comma after technology mean? Exactly. Is that a pause, or is that a separation of two values in a list? Is this a comma inside of as a thousand separator in a number? We need 3 separate commas that says, yes, I'm a comma, but I'm a pause comma, not to pause the reader here and not separate this from not. And so right now we don't know. We're asking artificial intelligence to determine that, and it can't 100%. It might be 80%, could be 99, could be 100, but the probability of that is very, very small. So before any progress can begin in our technology from where we're at today, we need to create a document technology. Information must be shared. We need only one editor. We only need one computer language that's all powerful, that can edit anything, and maps and math and dance and music and physics and chemistry and so on. It's a bricklaying and whatever, and available to every computer. So that every computer out there, irrelevant of hardware, operating system or anything, we should not care about operating system. This is the technology we're built in today. But it's software, people. I'm sorry, but those are just applications. Our operating system is just an application. Our editings that we have now are just applications. We don't need to be relying on those. And all of our documents should have no purpose. It's a document. This is what I created. My purpose was I needed to find my way to San Antonio, but you may want it for something else. It's not for me or the programmer or anybody else to decide what knowledge is used for, like a hammer. It's a tool. So it's like saying this hammer is only good for 8-penny nails. That's where our technology is today. Every application has a very specific. Microsoft Word only works on a Word document, period. It won't work on on some other editor's information, like Venture Publishing won't work on those documents, and it's version dependent. So, this hammer worked yesterday, it doesn't work today on 8-penny nails. You got to buy a new hammer. That's our technology. So, with an intelligent document technology, all technologies should be able to share the knowledge with the world. They should not need any extra source software at all. The document itself should know everything it needs to know and have that ability. Our computer languages could begin to evolve. We haven't come anywhere from our first assemblers, our current compilers. Our languages are only generating hardware instructions, and we only have like 4 types. We have a declaration of the type of the number of bits, and then we have an assignment statement and a jump statement and a move statement of this value to there. So we could expand that a 1,000-fold with better document technologies and be able to have more characters that actually represent something. When you go to a map, let's say it's an electrical diagram. Oh, I can see that's a transistor, and there's a diode. For somebody to have to type in diode and transistor, and so our software, we should not need software. And we should have absolute control and access to the information and logic we create. So if I type in a document, I don't need some other application for me or anybody else to use it, period. And security will be absolute at the hardware and software level. All computer technologies can evolve independently. What we want to get to is not waiting on anyone to make the tools you need to do your job. That's what the technology should be. I've been at this 50 years, and I'm still waiting for a decent editor. I'm still waiting for a decent compiler, a computer language. We have terrible flow control. We have no way to actually get my data out of my program and back in reliably. much less shareability. We have no shareability. We have so much proprietary data structures and substructures and just encoded and encrypted, and all these companies that land grab all of our computer technologies. We should not be relying on operating systems and hardware. We need to move, and we need to really create a document technology that is totally independent of any of our hardware, any of our existing hardware technologies. They're not free to use. Okay, well, thank you, and have a great one. Bye now.